What we're going to talk about today is some cutting tools that I have here that you can use to machine the SAE ports for, hydraulic fittings. O-ring boss, that's what we like to call it. That's this guy right here, the O-ring boss. It's a SAE English thread, imperial thread. This case, this is a SAE number 16. It has a 1 5/16 12 thread on it. And that's a little bit under, but that's a 1 5/16 12, and it seals with the O-ring right there. Now here's some examples of what I'm actually doing. I'm having to build these for a couple of cylinders. These are the parts that I'm custom building right here because you can't buy these things. Now some of these you can buy. There's plenty of fittings you can order. And here's one right here. This is for number 20, SAE number 20. Same thing, it's just a larger size. Okay, this is one that I used on that cylinder. This is the port for the extend side of the cylinder. But these are the ones that I'm making right here, and you can see how bad everything's just corroded. And this is for the transfer tube is what it is. But here's the one that I'm building for the transfer tube. It doesn't get threaded, this gets welded on right there. This one gets welded on, but this is where the fluid comes in, comes out of the transfer tube, comes down to this one, and then down through the barrel. This is the one that I'm having to make. So if you could go over to the lathe when you're building this kind of stuff and use some tools to get in here and cut this angle for the O-ring, cut your threads. Or if you got one of those newfangled CNC machines, you could spit out a bunch of these on the CNC machine just like manufacturers do with this stuff right here. But what do you do when you have a big old clunky part like this that's magnified 10 times, it's big and heavy? Well, sometimes it's not so easy to put something like this in a lathe. So what you want is a cutter, like an end mill, that you can just set this in the mill or a bore mill and go in there and cut this. That's where these cutters come in. Here's one that I've already used for a number 8. These are made by Scientific Cutting Tools. This one is a number 8 for a SAE number 8. And what you do is you machine your bore to your pilot size, and then you bring this in there and it cuts the profile. And then after you do that, you run your tap in there and you cut your threads. Alright, these are really nice high quality tools that they make. These are brazed on carbides, and then they go in there, they grind it between centers to the proper profile. So that's a number 8. So what I needed, that we didn't have, is a SAE 16 for this guy right here. So we went ahead and we went ahead and ordered a few. These are some of the more common sizes that we might run into, so we went ahead and grabbed a couple extras while we were ordering. So this is the one that I'm going to be using today. Look at that, the thing of beauty. SAE number 16. So I've already got these machined. What I did is I used a lathe, I drilled it and bored it to size 1 inch 225 is your pilot size. So then we'll run this in here like so, cut the profile, and then after we do that, we can set up the tap and tap it. So that's what we're getting ready to start on. We got 2 of those to make. I'm doing 2 of these, by the way. This one, I've already got one of these welded on. I got to finish machining these before I can finish out my welding. So I just wanted to show you this stuff. These are really nice tools if you've got to make O-ring boss ports on a part like this. Now this is just a protective coating that they put on them, in case you're wondering, called peel coat. You can usually just take you something, your multi-use tool here, and just kind of cut it. and peel her off there. Look at that. Some fine looking work. So what I'm going to have to do, I need to go put these back in the lathe. I wasn't sure exactly the size that this was going to be. I was just looking at some specs online for this particular cutter. I need to bore a few more thousandths out of this to give it a little bit of clearance in there. I don't want it going there and rubbing and creating a bunch of heat. So I'll do that, and then we'll set it up in the mill, and we'll go in there and we'll cut this thing like we're supposed to. Alright, we got our little mini production setup going on so that we can pull that one out and I can do this one without having to indicate it again. What I've done is I put a floor in the bottom of the vise right here. If I had to say, if I had one complaint to make about the Kurt vise, is that it's not flat in the bottom. So how many times you come over here and you want to set something down and you can't because it's right there. You got to put it off here on the side, or you do like this. You take you some parallels that you hope are even, and you can set your part there. We're going to use the vise stop and this little B block. Make sure it's pushed up against it, and we're going to slide it over till it just touches the vise stop, and we'll snug the vise. Now let's go ahead and find the center of that. That is saran wrap that you're listening to out there. They're wrapping up a crate. Okay, I think we're finally getting there now. We'll try to make it a little bit easier. Okay. That looks pretty good. Lock it. Okay, and then we'll zero out the DRO in case we need to move the table for whatever reason. All right. There's our little cheat sheet telling us our surface feet per minute to run these, and it also gives you your feed instructions there too. So we're using the uncoated tools, and we're going to be cutting carbon steel. So it's saying somewhere between 125 and 190 surface feet per minute. All right, the tool diameter, I'm just going to call it 1 15/16. That's 1 inch 921 measurement with some calipers there. So we just need to pick a number between that. Let's see, carbon steels, let's say 150. 150 divided by 1.937 equals, and then we're going to multiply that by 3.82. So that's about your RPM, somewhere around that. You can go plus or minus, it ain't going to kill anything. So 295, 300, somewhere around that range is what we'll spin that. All right, let's go ahead and give this thing a cut. We got her set around, 270 on the dial up here. Let's see if we clear. All right. So we're going to go down until this area here is touching the top of that tool, or top of the part, I mean. Go ahead and give it a little go juice. Thing's nice and lubed up. I'm just pecking it by hand, by the way. All right, you're there. There it is. We'll touch it one more time. Okay. No oil on the screen. Okay. There we go. Now, what we're going to do, since we're set up with the cutter, let's go ahead and swap this one out. We'll swap it out, mill it, and we'll go to our tapping. See if we can get it lined up again. Feels a little bit off. Yeah, I'm not liking that. Yeah, it's wanting to hit a little bit. Dang it. Where's it at? Let me go ahead and re-indicate that, because I can hear it. You can hear it hitting. Alright, we're going to leave it right there. I was off by, on the digital readout, it's 0.002. Not too bad. Alright, round two. That's better. So it was only 0.002. We still could have, I think we could have went with it. I wasn't sure how far out it was, really. There we go. We just touched the top. And that's it. That's all it takes. Makes it quick and easy when you got the right tool. All right, next step, we're going to tap it. All right, we're going to go ahead and run the tap in here. I got a center point in the end of the tap holding it. Got Will over there holding the quill for me. I just want to come just down to about where that hole is there. All right, we're going to try that. I'm going to go ahead and back off now. Thanks. All right, let me get the fitting over here. We'll try it. All right, there it is. And you just screw it down until it seats, preferably with a wrench. And there you have it. There's your hydraulic fitting connection. There's you a little closer look at it. All right, so we got our two fittings made up, looking nice. So I didn't mention what this is earlier. So this is where our cross tube is going to go in and get welded. What I do is I drill it to the same ID as your tube. In this case it's 13/16, and I use a 1-inch end mill because this is 1-inch diameter tubing, and I counterbore it so that it's got a nice fit. Yep, it's got a nice fit. All right, see, there you go. So one end gets welded there, and then the other end of the tube will have this one, same thing. It's just a drilled hole, 13/16, counterbored for 1-inch tube, and then that gets welded up here on the barrel. So to go up here like so. This is the one that I'm reconditioning, because the old transfer tube and everything was just so far gone. So this transfers the fluid that goes in here to the front side of the piston for a retract. What this does is allows the fluid to transfer to the other end of the tube, so that both of your hoses are connected on that end. Where this thing is located in the machine, both hoses come in and get connected on that end of the barrel. So this gets welded here, and then on the opposite end, this doesn't go here, but on the opposite end it'll look like this, and that'll just get stitched on each side just to hold it. Okay. Okay, I got the new fittings in the cross or the transfer tube welded on. As I said, you know, this one really you just got to weld each side just to hold it there. It doesn't have to be welded solid, because it's a blind hole. The fluid's going to come out and into your hose connection there. There's the one that pushes the piston out for your extend side. That'll be for your retract side. So you got a hole right there, fluid goes through. And I used flux core this time, by the way, instead of the stick. I've been setting up down here and doing a little bit more welding while I got this table. So one last thing that we got to do, I need to find some little pieces of flat bar, and I'm going to cut, and I'm going to put 3 little supports in here, as you can see. Move it with your hand. So put some supports in there, because a lot of times the people that handle this outside of our facility, they wrap a strap around it and they'll just bend that as soon as they get it. As soon as they get a hold of it, they'll just bend that, instead of taking the time to strap it up like they're supposed to. So I'll try to keep it as straight as I can. All right, there's our 2 cylinders finished up. This eye plate right here, I cut off the old barrel and re-welded it on this one. There's our SA20 fitting that we bought there, we welded on. So those are done. A lot of work goes into that stuff. And then while we're here, ponder that a little bit.